Right, so today we are going to discuss another, this is not a method lah. Generally, I call it as a special type of condition or concept. All right, this is not a method. So this concept can actually can be used in any methods in any question. All right, so please be reminded that this is actually not a method, it is actually a concept. Okay, right. So you need to know this word. We call it as mutually exclusive events. Right. So as a meaning for mutually exclusive event, it means the events that cannot occur at the same time. So we call them as mutually exclusive event. Okay. So when A and B are mutually exclusive, that means there's no overlap between them. Which means when you write out the probability for A intersect B, it can be equals to 0. All right. So if you look at the Venn diagram, you'll see that the two circles will not touch each other or overlap each other. Okay, so which means there's no overlap, no overlapping between these two events, and we call it as event A and B are mutually exclusive. So when you see this kind of Venn diagram, that means event A and B are mutually exclusive. Right, so when event A and B are mutually exclusive, you will get this formula, and you can apply it in your question to get a solution. All right, so I want to talk about this formula. Actually, this formula, it is originate from the addition rule. I don't know whether you still remember addition rule or not. Previously, we learned the addition rule, right? Which is A union B equals to PA plus PB minus A intersect B. So this is my addition rule. And because for our event here, our concept here, the A and B has no overlapping. So that means this is actually equals to 0. And when this is equals to 0, that's why you can get this equation. All right, so this particular equation actually originates from the addition rule. Okay, and when your A intercept B is equals to 0, you can get this. So usually I will tell students, if possible, if can, try. You have to make sure that when you want to use this formula, you have to make sure that that particular question is actually the event A and B are mutually exclusive event. If let's say they are not mutually exclusive, you cannot apply this formula. You have to go back to the addition rule. Okay, so let's have a look and see how we actually try to answer some question here. Okay, so you take out a card from a set of playing cards. Find the probability that the card is a club or a diamond. Okay, so you can use the common sense to answer this question if you want. All right, so to let you know that a club or means union, diamond means diamond. They want you to find this probability. Okay, if you are not so sure whether you can use uh, any formula, the formula that I showed you just now or not, then you always start with the addition rule. Okay, so according to addition rule is you're having the probability of the club plus the probability of the diamond, then minus club intersect diamond. Okay, so you are having 13 club cards. You are also having 13 diamond cards and minus the intersection of them. So if you can imagine, the club card belongs to black suit and the diamond is actually the red suit. Okay, so there will not be any overlapping between the black suit and also the red suit. Therefore, the overlapping is actually 0, or the intersection is already actually 0. So when you try to simplify it, you will get the answer half. All right, so you'll see that actually when I try to answer the question, I'm still using the original addition rule. Okay, then we go for part number 2. So for part number 2, they are asking for a club or all means union, a king, so K. Again, I will apply the addition rule first. So I'm having a club plus the probability of king and minus the probability of getting a club intersect with king. Okay, so now we are having 13 club cards in the set of playing card. Then how many king cards we have? So we are having spade king cards, heart king cards, diamond king cards, and also the club king cards. So in total, you're having 4 of them. So 4 over 52 and minus club intersect with king. So club is the suit, king is actually the picture card. All right, so you will realize that actually there's one club intersect with king card. So you're having 1 over 52. So what do you get? You'll get actually 4 over 13. Alright, so what I want to tell you from here is, okay, for these two examples, in the question, they will not tell you whether the events are mutually exclusive or not. Therefore, you need to figure it out yourself. Like for this one, because the club and diamond will not overlap, and you see that the probability of their intersection is equals to 0, therefore, you can actually make a summary that the club event and also the diamond event are mutually exclusive. So the same thing happened for this one. When they are asking you to find out the probability for club intersect with king, so you see that hey, there's a value here, it is not equals to 0, therefore you can make a summary that the club and king card are not mutually exclusive. Alright, therefore, in short, if let's say you want to answer any question, right, usually my suggestion is if you want to use the addition rule and you are not so sure whether are they mutually exclusive or not, no need to do worry about it. You straight away apply the addition rule will do. Okay. Right, then let's continue to example 10. Okay, so they are throwing 2 fair dice, and then this is the definition for event A. This is the definition for event B, and they're asking whether A and B are mutually exclusive or not. Okay, so to answer this question, there are more than one way for you, or more than one methods for you to solve it up. And then because here I see we are having 2 fair dice, right? So maybe for me, I think it will be good if let's say I can use the possibility space diagram as the method. Right, so I'm going to draw the possibility space diagram out. Right, so from here, I'm having my first dice. So for the first dice, I'm having the outcome 1, 2, 3, 4, 5, 6. And then for the second dice, also I'm having the second set of outcome with 1, 2, 3, 4, 4, 5, 6. Alright, so again, what is the total number of sample, the element in the sample space that we have? So if you count from here, there are 36 cells here. So that means the NS is actually 36. Okay, alright, so now I will want to start putting in the info into my possibility space diagram by looking at the event. So they tell you that event A is the score differ by 3 or more. Alright, so as an example, if I look at this one, the first one, when you have score 1 and 1, you take 1 minus 1, it is equals to 0. So it does not belongs to event A. Alright, so I will just leave it blank. Okay, so you check cell by cell. For this cell, when you take 1 minus 2 or 2 minus 1, you'll see that the value is not a 3 or more. Okay, therefore, this is also not the cell that I want. So it is not belongs to event A. So if you continue to check slowly, you will see that this is actually the cell that I want. This is belongs to event A because 4 minus 1, you get a 3. So it fulfills the definition for the event A, which is the score differ by 3 or more. The same thing happens for the next cell. 5 minus 1, you get a 4, belongs to event A. So 6 minus 1 equals to 5, also belongs to event A. So for all the cells that belongs to event A, I will highlight it with yellow color. Or maybe you can put a special sign when you want to answer the question. Okay, so the same thing happen. You need to check through all the possible cells. So if you go through it slowly, eventually you have all this as that is belongs to event A lah. Right, then this one. Okay, then the next one will be this. So all these are the cells that belongs to event A. Okay, so now I can start. I can try to answer the question already. Okay, so for the first part, they're asking for the probability of event A. So you just count how many of the cells that you highlighted in yellow color in your possibility space diagram, and you realize that okay, there are 12 of them. Therefore, it is equals to 12 over 36. Which is equals to 1 over 3 after you simplify them.